Okay, everybody, so we are going to do this review. These numbers correlate to the numbers that are on your guys' Desmos assignment. So number 1 is obviously number 1 and 2 and 3 all the way through number 12. I'm going to go through and hopefully make this video without making too many mistakes, and we can go ahead and see. If you do not have one, you'll need a calculator to be able to check the proportionality of it. Let's get started. Problem number 1. I see that there's two triangles. Neither of them have any angles given. So I know that to angle, I'm going to just write them down right here. Angle, side, side, and side, angle, side. I know that the two that have angles involved aren't going to be it, so I'm going to be checking for side, side with these three. Let me just zoom this in a little bit more so you can see exactly what I'm going to do. So I like to go with the largest side first. So the largest side here is 55 and the largest side here is 25. We can't just randomly choose any side to compare to another side because remember, they have to be proportional. There we go. They have to be proportional. So I'm going to start writing my proportions here. Let's say 55 compares to 25 as the next largest one, which is 44. Compares to 20 because they are the two middle ones, 44 to 20, and then the last one, 37 to 17. 37.4 compares to 17. Now what I'm going to do is I'm going to take my calculator, there you go, and I'm going to just calculate them out. 55 divided by 25 gives us 2.2, that's nice. 44 divided by 20, 2.2. Oh, we're looking good. And the last one is 37.4 divided by 17, 2.2. Perfect. They are all the same. Now, if you were to flip these and do the small triangle over the large triangle, you would get a different number here. This number doesn't mean anything except that they are proportional. If you did, like let's say you did 25 divided by 55, and we get 0.45 repeating, all of these would be 0.45 repeating, and we see that they're the same, so this is true by side, similarity. Cool. First one, done. Let's look at number 2. Number 2 has a congruent angle, and we know that this angle is congruent to this angle, so these are similar by angle, similarity. And we know these are similar because these are vertical angles. And vertical angles are always congruent, so these are similar by angle, similarity. Let's check number 3. Number 3. Okay, number 3 is a little weird because a lot of people want to just compare 28 to 7 and 30 to 8, but we can't do that. We can't do that because they're not sides of a triangle. This is just a piece of a triangle. So what I like to do for these is I like to draw the triangles out. I know it takes a little more time, but trust me, it's worth it. This side is 28, this side is 30, and we don't know this side. Now we're going to draw the large one. The larger one is about the same shape, close enough. This side is now 28 plus 7. 28 plus 7 is 35. Think. 28 plus 7 equals 35. Oh my gosh, my brain's dying today. And 30 and 8 gives us 38. Okay, now you're thinking to yourself, we don't know this side either. Well, I know it's not angle. I don't think it can't be side. Maybe it's side, angle, side. Oh, wait a minute. They both share this angle here. So this angle is congruent to this angle because it's the same on both triangles. That guy is that one and that one. Boom. So this looks like side, angle, side. I got the congruent angle down. Now I need to check some proportions. 28 must compare to 35. So 28 over 35 will have to be 30 over 38. Now, if these are exactly the same number or the same decimal when I do this, then I would say these are similar triangles by side angle side similarity. Let's check and see. There we go. So 28 divided by 35 gives us 0.8, and 30 divided by 38 gives us, oh, so close, 0.789. Now, I know what you're thinking, Mr. Hayden, those are close enough. Close enough doesn't matter when we're talking similarity. They must be exact. Even if we were to round this, which is really, 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 really close to 0.8, we can't round in here. They have to be exactly the same. Why? Because it says we're dilating this side by this amount, and if we dilate this one by something close to it, but not exactly, they will no longer match up. So this is not similar. Not similar. These ones where there's two triangles on top of each other, always split them up. It makes it a lot easier to see. And you won't make that mistake. Number 4. Well, I know two angles here and two angles here. I don't know what this third angle is, and I don't know what this third angle is, so I'm going to calculate it. 106 plus 29 gives us 135 minus that from 180, and we get this one here is 45 degrees. Now I don't even need to find this one. Well, I know it'll be 106 because we have 45, 45, 29, 29, so this one has to be 106. But all we really need are these two, and we can say, yeah, these are similar by angle-angle similarity. Because they have two angles that are congruent. Actually, they have all three, but we only need to find two. Number 5. Number 5 looks to me like side angle side, because I know by the vertical angle theorem that these two angles have to be congruent. Now I can start comparing sides. Be careful when you do this. Remember, we must compare the largest side of this triangle to the largest side of this triangle. It doesn't matter which one goes on top or bottom, as long as we're consistent with that. But let's find the largest side. Here it is. Largest side, 70. Largest side over here, 56. And that will compare to 60 over 48. Let's check and see. If these are exactly the same, then we know that they are proportional. 70 divided by 56 gives us 1.25. And 60 divided by 48 gives us 1.25. So I have proportional sides with a congruent angle between those two sides. I know this is similar by the side angle side similarity theorem. Cool. Number 6. Obviously, we're looking at side here. I know because there's no angles available. So let's just start comparing. Let's go largest side here, 96, to the largest side here, 54. So 96 over 54. Now, notice I'm doing the larger triangle over the smaller triangle. As long as we're consistent with all of our ratios, with larger over smaller, larger triangle over smaller triangle, that will work perfectly fine. Now we just have to match up our sides. Next largest is 80. Next largest is 45. So 80 over 45. And then the last one, 64 over 36. If these give us the exact same ratio or exact same decimal, then we can say they are similar by side. 96 divided by 54 gives us 1.77777 repeated. Say 1.7 repeated. And 80 divided by 45 gives us 1.7 repeated. And let's see if this one gives it to us. 64 divided by 36 gives us 1.7 repeated. So I know that these two triangles are similar by the side similarity theorem. I think you guys are getting the hang of this, but let's keep going. Oh, right when I say that, we come to a tricky one. This one has no sides and no angles, but it does tell us something. It tells us that this side here and this side here are parallel. When I see parallel, I think back to my theorems. Parallel lines cut by a transversal. That tells me two things. It tells me that this angle will be congruent to this angle, because if these are parallel and this is our transversal, then these are corresponding. But unfortunately, it tells me nothing about this angle and this angle. Unless there was another line that crossed these two parallel lines, unfortunately there's not. There's not. It's not there. Yeah. So what does that mean? It means that there is not enough information, so we can say not similar. That only gave us one set of angles that are congruent that we know. The other ones, there's no way to figure them out. There's no mathematical way or no theorem to use to prove it, so we'll say not similar. Oh, my favorite, two triangles stuck together. Let's break these things up and redraw them. Here's the little one, which is 10, and, ooh, we got to do a little math here. This whole length is 21 minus 6. Then this is 15. Because if this whole thing's 21 and we subtract 6 from it, then that makes this piece right here, the remaining 15. We don't know this side. All right, now let's draw the big one. We know this side is 21 and this side is 10 plus 4, which is 14. And we know that they share this angle. So we're looking at side angle side here. Let's write our two ratios for our two sides. Large side, 15 over 21. And we'll compare that to 10 over 14. Let's calculate it. 15 divided by 21 gives us 0.714. 0.714. And 10 divided by 14 gives us 0.714. This is equal to that, so we know that these two triangles are similar by the side angle side similarity theorem. We're almost done. 72 and 72, and I see vertical angles are used a lot here. Whenever you have two triangles that are kind of connected or have vertical angles, I'm looking at angle, angle, congruent, 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 angle, angle, all day. Angle, angle, similarity. Angle, angle is my favorite because I don't have to do any math. I don't have to use my calculator. I don't have to write any ratios. I don't have to check for proportionality. I just need two congruent angles. Number 10, I see that they have a congruent angle of 38 degrees. So we're looking at side angle side here. Let's see. Largest one is 28. Largest one here is 20. So 28 over 20. Hopefully that'll be equal to 21 over 15. Let's see. 28 divided by 20 gives us 1.4. And 21 divided by 15, 1.4. Cool. So these are similar by side angle side similarity. And I believe we have two more, number 11 and number 12. They're on a separate sheet of paper over here. We'll just do that. All right. Number 11. I see a vertical angle theorem coming in play again. Cool, so I'm looking at side angle side. Let's start writing some ratios here. The largest is 95. The largest over here is 72. So 95 over 72. We'll compare that to 87 over 68. 87 over 68. If these are exactly the same, then I know they are similar. 95 divided by 72 equals 1.3194 repeating, and 87 divided by 68 equals 1.279. These are not equal, therefore this is not similar because the sides are not proportional. They do have a congruent angle between them, but the sides are not proportional, so this is not similar. Our last one. Oh, of course, we got some ones that are stuck together, so I split them apart. There's my small one. I know that it will share an angle with the large one right here because that angle R is the same for both triangles. This is 35 and this is 30. Oh, and this is 25. That's cool that they gave us this side. And let's draw the large one. This is 35. This is 30 plus 12 is 42. And 35 plus 14 is 49. And they share this angle. This is cool because we can actually choose which method we would like to choose or to look at. We can either choose side, 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 or we could choose side, angle, side, since they share that angle. I'm always a fan of doing less work, so if I have to write one less per portion, that's good for me. So let's try for side, angle, side. And let's compare. We have to compare the two sides. If we're going to do side, angle, side, we have to compare the two sides that are creating this angle, because the angle has to be between them. So let's see. We're going to do this side, over this side, and this side. So 35, we'll do the smaller one over the larger one. So 35 is the side there over 49. 35 over 49. And then 30 over 42. It's kind of neat that we could choose which ones to do. Maybe you guys did maybe you did side, 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 and we will see. If one of them works, though, the other one will work as well, because that's how similarity works. So now let's do 30 divided by 42, and we get 0.7142. Perfect. They are exactly the same. So I know since they share that angle, that side, angle, side will work. So these are similar by side, angle, side, or side, side, side similarity, depending on. Now this is the work that you would show. This right here is the work that you would show. If I said, like, show your work on this, this is the work you would show. I hope this has been helpful to kind of assist in your learning of the three similarity theorems that we have learned. All right, I'm going to post this and you guys can check your work.